we present ITAA, an intelligent trajectory-driven outdoor advertising deployment assistant. Outdoor advertising is a $29 billion market. More importantly, it is expensive. For example, renting 500 billboards will cost $7 million per month in New York. Improving the advertising influence by 5% means save about $350,000 per month. Therefore, a good renting strategy is important. However, the advertising companies don't provide the renting strategy. For example, the American biggest advertising company Lamar only shows the basic billboard information. Our system helps users to find the optimal billboard deployment strategy. It accepts the user's input and returns a feasible billboard set. But how can we find the optimal strategy? For answering this question, we will introduce how a billboard influences an audience first, 2 influence models, and our framework. There are 3 billboards. Each billboard is associated with a radius circle, which represents its influence range. Intuitively, if a billboard is close to a trajectory along which a user or vehicle travels, the billboard influences the user to a certain degree. Without loss of generality, we adopt 2 influence models with 2 respective goals. The first one is OTIM. We assume that a one-time influence of the billboard to an audience is enough. Our goal is to maximize the number of distinct users. In this model, an audience will be influenced after seeing the advertising once. It will be counted as an overlap if this audience is influenced by more than one advertising. The second influence model is ICIM. It is based on the observation that effectiveness of advertising repetition varies from one person to another. Our goal is to maximize the influence of advertising based on ICIM. We assume that the influence of billboards is small, when an audience only saw the advertising a few times, while it will increase dramatically upon seeing more, which means we need to influence audiences multiple times. Therefore, we build ICIM based on the logistic function, since it is widely adopted in the advertisement market. This leads to a challenge. ICIM is non-submodular. Now we briefly introduce the solution. It's worth noting that this problem has been proven NP hard. For the OTIM, we first partition all billboards into several clusters based on their influence overlap. Then we find the local optimal strategy for each cluster. Finally, based on these local optimal strategies, we use dynamic programming to find the global optimal strategy. For the ICIM, because it's non-submodular, a greedy-based approach doesn't work. Therefore, we propose an upper bound estimation method that tightly upper bounds the logistic function value. Based on this method, we propose a branch and bound framework. We give the approximation ratio for both solutions. The front end provides users with an interactable UI that supports 4 sub-functions. Based on different demands, OutSystem invokes the related algorithms to find the optimal deployment strategy. This is the user interface. A user can zoom in or zoom out the map view to explore different levels of details. All basic information such as the budget, total cost, balance, and influence are shown in top of the sidebar. User can specify several deployment ranges, can change influence model and distance threshold lambda. The billboard list displays the selected billboards. Strategy comparison function helps users in comparing different strategies. Now, we demonstrate how to use our system. The default search range is the current displaying map view. Let's assume the user John, his budget is $500. After setting budget and clicking the auto selection button, all selected billboards will be changed to blue icons and shown in the billboard list. The trajectories influenced by these billboards are displayed as purple lines. He can remove any billboard that he doesn't want to rent by clicking the X button. By clicking one billboard, John can know which trajectories are influenced by this billboard. For the unselected billboard, all influenced trajectories are displayed with green lines. The detail information of this billboard will be displayed if user click right mouse key on this billboard icons. All information is updated in real time. Manually adding billboard is also allowed. Ignoring the over budget alarm, John adds this billboard manually. For now, he is satisfied with this strategy. But he still wants to explore more billboard combination. So he can save this strategy. As you can see, the previous one has been saved in the strategy list. Now, we assume John changed the influence model to OTIM. We can find that the trajectory's color is lighter comparing with ICIM. It is because in OTIM, trajectory line is not transparency, since one-time influence is enough. In ICIM, multi-times influence will make the trajectory line change from dark to light. For the selected billboard, the influence trajectories will be highlighted with yellow lines. After saving all ideal strategy, John can review any of them in strategy list. The deployment strategy will be recovered on the map view. Thank you.